All right, welcome back. Now, in our widget controller for the overlay, we have a to-do. In onInitialize startup abilities, we want to loop through all of our ability system components, activatable abilities, and we want to look up their info from our data asset, ability info. Now, I don't want to reach in and get that gameplay tag container and loop through it right here. I'd rather do it in a more self-contained way where we don't have to expose the contents of the ability system component so much. So what I'd rather do is make a delegate that I can bind a callback or a lambda to and pass that over to the ability system component, which can then loop through all of its activatable abilities and do something for me. So here's what I mean. I'm going to go over to Aura ability system component and make a delegate for each ability. So I'm going to declare, and I'm not even going to make this multicast. I'm just going to declare delegate, and it's going to be one param. Now, I'm going to call this F for each ability, and it's going to take a single input. It's going to be a const reference to an F gameplay ability spec. Because as we loop over all of our activatable abilities, those are ability specs. So I want a way to loop over all of those abilities. In other words, I want a function on the ability system component that can take in one of these for each abilities, which will have a function bound to it, and loop over all of my abilities and call that function that's bound to this delegate. So I'm going to create that function here. It's going to be public. And I'm going to call it for each ability, void for each ability. And it's going to take this delegate, F for each ability, and it's going to take it by const reference. And I'm going to call it simply delegate. And what does for each ability need to do? It needs to loop through all of its activatable abilities. So we'll have a for loop. We're going to say for const F gameplay ability spec. Const reference, of course, and this will be called ability spec, and we're looping through all of our activatable abilities. We can get those with get activatable abilities. And what we're going to do is if that delegate has a callback bound to it, we're going to execute that delegate. So we'll take the delegate and call execute, and we can call execute if bound and pass in the ability spec as this delegate requires the ability spec. Now, execute if bound will return a Boolean. If the delegate has no callback bound to it, then we can get that false value. So we'll say if, and we can say if not, execute if bound. So this will still execute it if it is bound, but if it's not bound, we'll get that false value returned. And in that case, we can log. We can log an error. We can say UE log. We can use our new fancy log aura. Remember, autocomplete included my aura log channels.h when I typed that. We're going to log an error, and it's going to say failed to execute delegate in. And if we want to log the name of a function, we can use %hs. And what are we going to pass for that? Double underscore function, double underscore. This is a nice, handy way to just log the name of the function we're in for each ability. Pretty nifty. So we now have this for each ability, and it loops over get activatable abilities. Now, there's another reason for doing this in the ability system component and not in the widget controller, and that is as we're looping over abilities, we have to be careful because abilities can change status. They can become no longer activatable, for example. Maybe they're blocked by a certain gameplay tag, etc. So a good practice when looping over this container is to lock that activatable abilities container until this for loop is done. And we can do that with f scoped ability list lock and create an active scope lock. We're going to call it active scope lock. And this requires the ability system component, not by pointer, but by reference. So we need to dereference this and pass it in. So with this, we'll be safe to loop over all of our activatable abilities because the list will be locked and it'll keep track of any abilities that are attempted to be removed or added and wait until this scope has finished before going and mutating that list. So this is a safe way to do it. And this is something I'd rather just handle here in the ability system component rather than from outside of it. Make sense? Okay, so now we have this for each ability. And back in our overlay widget controller, I'd like to do something for each ability. So what I'm going to do is create a lambda to bind to F for each ability. So we'll make an F for each ability here called, I'll just call it broadcast delegate. And I'm going to bind a lambda to it. Broadcast delegate dot bind lambda. And what can I bind to it? I'm going to bind a lambda. So we're going to use square brackets, parentheses, and a function body like we usually do. And I'm going to put those curly brackets on their own lines so we can kind of better see what the function body looks like. I can go ahead and keep that closing parentheses there. And here I want to do something, right, for each ability. Now, what I want to do for each ability, we have the to-do right here. We want to get information about all the given abilities by looking up their ability info. Now, our ability info, it's a variable here on the widget controller, and it has that function we made, find ability info for tag. So if we have the tag for a given ability, well, then we can get its ability info. But all we really have here in this lambda is the ability spec. That's right. We need to make this lambda have the correct signature if it's going to be bound to broadcast delegate. This can only take something that can receive a const f gameplay ability spec reference, right? We're going to call it ability spec. And here in our lambda, we need to figure out how to get that ability tag from the ability spec. And in addition, ability info can't be accessed from within this lambda if we don't capture this, right? But still, we need a gameplay tag to pass into find ability info for tag. So let's make another to-do here that says need a way to figure out the ability tag for a given ability spec. So how are we going to manage that? Well, as long as all of our abilities have a given tag in its ability tags, we can check if it has a parent tag in its tag hierarchy. So we could create a nice utility function on the ability system component for getting the tag for any given spec. So we're going to go into our ability system component and make a nice utility function that can do that. It's a function that I'd like to return an fGameplay tag from. And I'm going to call it getAbilityTag from spec. And it's going to take in a const fGameplay ability spec reference called ability spec. And it's going to return its ability tag. So let's go ahead and create the definition for this. And it's going to be relatively simple. We need to get the ability tags from this ability spec. Well, to get the ability tags, we take the ability spec, and it has a .ability, which is the actual ability. And this ability is a t-object pointer, so we can call get on that. And from that pointer, we can get ability tags. So kind of a lot of indirection here, and we should definitely make sure the ability is a valid pointer. So we'll say if ability spec .ability, then we'll get the ability tags. And this is a gameplay tag container. So we're going to loop through it. We're going to say for fGameplay tag in this container. So we're going to drag that up in here. And what are we going to do for each tag? We want to see if it's an ability tag. So we can say if tag.matches tag. And we're not going to use matches tag exact. We're just going to see if it contains ability in it. So we can say fGameplay tag request gameplay tag. using the fname of abilities. So basically, for a given ability spec, we're going to look at that ability spec's ability tags. And assuming it only has one ability tag that has abilities in it, then we're going to return that tag. And if we reach the end, we're going to return an empty fGameplay tag. And if you wanted to, you could log an error in that case, but I'm okay with just returning the tag if it's there. So now we have a nice function for returning an ability tag. In fact, this can even be a static function because it just takes in something and returns something. So really, this could be marked static, like that. Now that we have this handy function, let's go back to our widget controller, where we have this line commented out, where we're trying to find the ability info for a given tag, and we have its spec. So we need to take our Aura ability system component and call getAbilityTag from spec, passing in our ability spec. Now we're trying to use Aura ability system component in our Lambda, and that is not captured either. So we have to capture that. It's just a pointer. We can capture it by value. That's totally fine. And now that we have our ability tag, now it's possible to find the ability info. Now we have an fAura ability info struct. We're going to go ahead and create a local fAura ability info. We'll call it info. So now what do? We have the info. We want to broadcast that up to our widgets, right? But we have to make sure it's all filled in completely. For one, we're not setting its input tag, and we don't know what its input tag is. So yet again, we need a nice way to get that from our ability tag. Remember, the input tag is one of the dynamic ability tags. When we give the ability, we're adding to its dynamic ability tags the startup input tag. But that's only for our default abilities. Soon we'll be equipping abilities dynamically, and we'll have to assign input tags to those. So I'd like another utility function to be able to get the input tag from the ability spec. So just like get ability tag from spec, we're going to have get input tag from spec. So let's make another function that returns an fGameplay tag. We'll call it get input tag from spec. And just like get ability tag from spec, it's going to take in a const reference to the ability spec. Let's go ahead and just really quickly make this function. So how is this going to work? Well, we're going to loop over our dynamic ability tags this time because we know that the input tag is in that gameplay tag container. So we're going to say for fGameplay tag in ability spec, and from the ability spec, we can get dynamic ability tags directly. We don't have to get it from the ability. And with that, we can match the tag. We can say if tag dot matches. Again, we're not using matches tag exact. We're just going to match against the input tag. So we're going to use fGameplay tag request gameplay tag fname input tag. And again, we should only have one input tag at a time. So just like our ability tags. And we can go back to Aura gameplay tags and remember we have our input tags, right? Input tag.lmb, input tag.rmb, and so on. So we're going to return that tag. It's going to be return tag. And if we never return the tag, we have to return an empty fGameplay tag. Like so. So now we have get input tag from spec. And now we can call that to get our input tag. So we can come back to our widget controller and we can take our info and set its input tag by getting our ability system component, Aura ability system component, and calling our new function get input tag from spec, passing in the ability spec. And now our info struct has its input tag set, and that's all great. Now the last thing we want to do is broadcast this fAura ability info. In other words, we need some kind of delegate to broadcast so that our widgets can respond to it. We need an ability info delegate. So yet again, we're going to make another delegate up here in our overlay widget controller that can broadcast ability info. Now, I'd like this to be a dynamic multicast delegate, as this will be bound to in blueprints and multiple blueprints to boot. So we're going to say declare dynamic multicast delegate, and we're going to broadcast with one param because we want to broadcast that info struct. And I'm going to call this fAbilityInfo info delegate. Actually, we can call it info signature, and then we'll create a delegate of this type. And of course, it needs to take one input parameter. We're going to use const f or ability info. That's going to be forward declared because this is a reference. And we can do a comma with the name of that input parameter. And now our ability info signature can be added as a blueprint assignable. We're going to call this ability info delegate. It'll be blueprint assignable, and we can put it in the category gas messages, and our overlay widget controller can simply broadcast ability info delegate passing in info. Now, all of this is just inside of a lambda, which is being bound to broadcast delegate. We want to do this, we want to call this lambda for each ability, right? That's why we created that for each ability function on the ability system component. So we're going to take Aura ability system component for each ability, call that function passing in our broadcast delegate. So when onInitialize startup abilities gets called, we create a broadcast delegate and bind a lambda to it. That lambda creates an fAura ability info, which is set by calling find ability info for tag on our ability info data asset. We need the tag for each of our ability specs, and our lambda can receive an ability spec by const reference. So find ability info for tag needs that tag, which is why we created a function on the ability system component to get the ability tag by looking up an ability spec. Once we get that info, we now have the fAura ability info, but we need to set its input tag. So we created another function on the ability system component that can take an ability spec and look up its input tag from its dynamic gameplay tags. Once we have that, we set the input tag on that info. It's very important because we need to know which input tag is associated with which ability. So once we have that info struct, we're passing it into broadcast, broadcasting it so our widgets can then receive that broadcast and then do their own thing with that info. After defining the lambda and binding it to our for each ability delegate, we call for each ability on the ability system component, passing in that delegate, and then the ability system component in for each ability is going to loop through its activatable abilities using an active scope lock and execute the delegate that we've passed in. So we're passing in one delegate and it'll be executed for all abilities in our activatable abilities. Now, get input tag from spec can also be marked static, so these two handy utility functions can both be static. So making sure that is there. And now things are all in place. And the only thing left is to go into our widgets and register some kind of event to bind to the ability info delegate so it can receive that ability info. Now, another thing is here we are creating a lambda and passing it into a function. So recall that we've done this before, and we could easily replace that lambda with a function pointer. So that's something that I leave to you as an optional exercise if you'd like to do that. But for now, I think we're ready to start binding events to our delegate we're going to broadcast for each of our abilities, and we'll do that next. So excellent job, and I'll see you in the next video.